Not metaphorically, not roughly, exactly. At this very second, the chair you're sitting in, the building around you, the ground under your feet, all of it is screaming through the cosmos at a speed that would carry you from New York to Los Angeles in less than 8 seconds. You feel nothing. That's the part that should unsettle you. Here's what nobody tells you. That stillness you feel? It's an illusion. And it's so complete, so perfectly built into the physics of this universe, that every human being who's ever lived, every philosopher, every king, every kid who looked up at the stars, was moving at this exact velocity the whole time. And none of them knew it. But here's the thing. That number, 1.3 million miles per hour, that's not one speed. That's the sum of multiple velocities stacked on top of each other like layers of a hurricane. And each layer, once you actually understand what it means, changes something about the way you see yourself. By the end of this, you won't feel still again. Not ever. Let's start with the obvious one. The one you've known since 3rd grade but have never actually felt. Earth is spinning. Right now, if you're anywhere near the equator, that rotation is carrying you eastward at 1,040 miles per hour. That's faster than a bullet fired from a high-powered rifle. Faster than any aircraft humanity's ever put into commercial service. And the coffee in your cup isn't sloshing. The air isn't screaming past your face. Nothing gives it away. Here's why. You and the air and the coffee and the building and the entire atmosphere are all spinning together, locked into the same rotation, like passengers inside a perfectly sealed carousel that's been going since before the first fish crawled onto dry land. You can't feel the motion because there's nothing to feel it against. But wait, here's where it gets crazy. If that rotation stopped suddenly, completely the way a car hits a wall, everything not bolted to the bedrock of the planet would keep going eastward at 1,040 miles per hour. Every ocean, every skyscraper, every living thing. The kinetic energy stored in Earth's rotation right now is roughly equal to 10 billion nuclear weapons. All of it, silent, beneath your feet, right now. But that spin, that's the smallest layer. That's just the beginning. Earth doesn't just spin, it runs. Our planet orbits the sun at 67,000 miles per hour. That's 18.5 miles every single second. In the time it takes you to read this sentence out loud, Earth has moved roughly 100 miles along its orbital path. 100 miles. One sentence. Now here's what most people never stop to think about. That orbital speed isn't constant. Earth moves faster when it's closer to the sun. In early January, we're actually 3 million miles closer than we are in July, and we're moving about 1,000 miles per hour faster because of it. The sun's gravity is pulling harder, whipping us through the turn like a stone on a string getting swung through a tightening spiral. We don't feel that acceleration either, but here's what nobody talks about. If our orbital velocity dropped by just 0.5%, just 335 miles per hour off a speed of 67,000, our orbital path would start to decay, slowly at first, then faster. Earth would begin a long, irreversible spiral inward, toward the sun. It'd take tens of thousands of years, but it'd be locked in from the moment it started. A 0.5% change in speed. That's the margin between inhabited planet and consumed by the starred orbits. But that's not the terrifying part. We haven't even left the solar system yet. Here's the thing. The sun isn't sitting still at the center of the solar system while the planets orbit it. The sun, and every planet, moon, comet, and piece of dust in our entire solar neighborhood, is orbiting the center of the Milky Way galaxy. At 514,000 miles per hour, let that land. Everything you've ever known, every city, every mountain range, every ocean, every human being who ever drew breath, is aboard a solar system that's hauling through space at 500,000 miles per hour, swinging around a galactic core so dense that 4 million suns could fit inside the black hole sitting at its center. And we're not even close to the middle. We're in the suburbs, about 26,000 light years out from the core, in a quiet stretch of the Orion Arm, moving in a wide arc around that center. One full trip around the Milky Way takes approximately 225 million years. The last time Earth was in this exact spot in its galactic orbit, the dinosaurs hadn't shown up yet. The dominant life form on this planet was a small, pig-sized reptile ancestor that had zero concept of the sky above it. We've barely moved in galactic terms. But wait, before we get to the final, biggest layer of motion, you need to understand something about your own body right now. Stop, just for a second. Don't move. Horror, visceral section. Second person. Right now, the atoms in your body are vibrating. Every single one, the iron in your blood, the calcium in your bones, the carbon threaded through every cell in your body, vibrating constantly because they're above absolute zero, which means they've never, not once in the entire history of the universe, been perfectly still. The electrons in your atoms are moving at roughly 1% the speed of light. That's inside your hand, right now. Your body isn't a solid object. It's a temporary agreement between particles that are mostly empty space, moving at speeds your nervous system was never built to detect. All of it hurtling through the cosmos at 1.3 million miles per hour, while you feel absolutely nothing. You look at your hand. It looks still. It is not still. Nothing, absolutely nothing has ever been still. The stillness you experience every single day of your life is the most successful illusion in the history of the universe. And honestly, that's terrifying. But here's where it gets genuinely vertiginous, because we still haven't added the largest velocity yet. The Milky Way galaxy itself, along with Andromeda, our local group of roughly 50 galaxies, and thousands of other galaxy clusters in our cosmic neighborhood, is being gravitationally pulled towards something enormous. Scientists call it the Great Attractor. It sits about 250 million light-years away in the direction of the constellation Centaurus. Get this, it's a gravitational anomaly so massive it carries the equivalent mass of tens of thousands of galaxies, and it's pulling our entire galactic neighborhood toward it at approximately 1.4 million miles per hour. Here's what makes this genuinely unsettling. We can't fully see it. The Great Attractor sits almost perfectly behind the dense star fields and dust clouds of our own Milky Way's disk, what astronomers call the zone of avoidance. We're being pulled towards something we're partially blind to, across a distance so enormous that light takes 250 million years to make the crossing. Scientists didn't believe it at first. The data kept showing that our galaxy was moving in a direction and at a speed that couldn't be explained by anything visible. So they ran the numbers again and again. And the conclusion held every single time. Something vast is out there. It's pulling everything. And we are, right now at this moment, moving toward it. This next part is the reason I can't sleep. Relief, then wonder. Now add it all up. Earth's rotation up to 1,040 miles per hour. Our orbit around the sun, 67,000 miles per hour. The solar system's orbit around the galactic center, 514,000 miles per hour. Our galaxy getting pulled toward the Great Attractor, roughly 1.4 million miles per hour. Stack those vectors. Account for direction, run the math. You land somewhere between 1.3 and 1.4 million miles per hour. Every second of your life, since the moment you were born, while you slept, while you sat in rooms and felt completely, perfectly still. Mind blow, final revelation. Here's the thing that's going to stay with you. There's no fixed point in the universe to measure truly still against. No cosmic lamppost, no absolute anchor. Einstein proved this. The universe doesn't have a center of rest. Every velocity we just walked through is relative to something else that's itself moving, which means stillness as an actual physical condition may not exist anywhere in the universe. Not on any planet, not in any empty void between galaxies, not in the coldest, most isolated cubic meter of intergalactic space. Motion isn't something that happens to matter. Motion is what matter is. You're not a stationary creature having occasional experiences of movement. You are motion itself, briefly, improbably, arranged into a shape that can look up and wonder and ask where it's going. Every philosopher who ever sat in a quiet room thinking about the nature of existence was sitting in that room at over 1,000,000 miles per hour. Every poet who ever wrote about stillness was hurtling through a universe that doesn't offer any. We've never stopped moving. Not one of us. Not once. And somehow, in all of that velocity, in all of that scale, in all of that motion across distances, the human mind wasn't built to hold. We found each other. If that left you unsettled or strangely grateful, or both at once, subscribe. There's more where that came from. You're moving through space at 1.3 million miles per hour. Right now you're sitting completely still, or so it feels. But right now you're moving through space at over 1.3 million miles per hour, and that number is built from layers of motion stacked on top of each other, each one more staggering than the last. Earth's rotation, our orbit around the sun, the solar system's journey around the Milky Way, and the gravitational pull of something enormous 250 million light years away, called the Great Attractor. In this video, we break down every layer of that velocity, what it would mean if any of them stopped, and what it says about the nature of stillness itself. Spoiler, true stillness may not exist anywhere in the universe. Sources drawn from NASA, ESA, and peer-reviewed astrophysics. No speculation, just the actual numbers and what they mean for every human who has ever lived. Subscribe for more videos that make the universe feel personal. Space motion speed, how fast are we moving through space? Great Attractor explained, Earth speed through space, Milky Way orbit speed. Are we moving through space? Space Documentary 2024, Speed of Earth Rotation, Galactic Motion explained. What is the Great Attractor? Cosmic velocity?